Here we will move on to an extension from Chapter 9 called vertex form. This is vertex form. It is where y equals a times x minus h squared plus k. And what we really are interested in is this part right here. It says the characteristics of a graph of y equals a times x minus h squared plus k has a vertex at hk. So your x value of vertex is this value, and it's always going to be the opposite. So if it says minus 3, then your x value will be plus 3. And then plus k is your y value of the vertex. So again, the vertex is hk. The axis of symmetry is whatever your h value is. And remember, the axis of symmetry is an equation of a line, so we have to have x equals. If your a value is greater than 0, it's going to open up, just like this. If your a value is less than 0, so negative, then it's going to go downwards, just like we've done before. So for example, if I had y equals x minus 3 squared plus 2, the vertex would be at positive 3, positive 2. Your axis of symmetry would be x equals 3. Since there wasn't a number in front of here, a would equal 1, so it would open upward. And as a reminder here, we're still going to use the 5 steps in order to graph these equations in vertex form. And here's example number 1. Graph y equals x plus 1 squared minus 1. So our first step is to decide whether it goes upward or downward. Our a value would just be a 1 here, which is positive, so it would go upward. Step 2 is to do the axis of symmetry. You find your axis of symmetry by the x value of your vertex. And if it's in vertex form, it's really easy to identify what the axis of symmetry is. If you remember from the previous slide, it was always x minus h squared plus k. So your h value is actually the opposite of what you see in here. So if it says plus 1, that means our x value is negative 1. So the axis of symmetry is at x equals negative 1, so I'm going to go to my graph and I'll do a dotted line along x equals negative 1. Step 3 is to find the vertex. We already know the x value of the vertex is negative 1 from when we found the axis of symmetry in step 2. The y value be whatever number it is out here. We did the opposite when we found the h value, but we stay the same when we do the k value. So our vertex would be negative 1, negative 1. So now we'll go to the axis of symmetry and put a dot right here at negative 1, negative 1. And we know that starting from this point, our graph is going to open upward as we move along. Step 4 is where we find the y-intercept, and this time, when we're in vertex form, it's not going to be as easy as when we were in standard form, where it ended up just being the c value. But just remember that for the y-intercept, the x value is 0. So we're going to plug 0 in for x. So 0 plus 1 is 1, 1 squared is 1, and then 1 minus 1 is 0. So our y-intercept in this case was 0, 0. This is not going to be the case every time where the y-intercept is 0, 0 when we're in vertex form. That's just how it ended up for this problem. So I'm going to go to the y-axis and put a point at 0, 0. Then using symmetry, since our y-intercept was 1 unit to the right of the axis of symmetry, I know I have a point 1 unit to the left, so I'd have a point right here as well. Step 5 is where we do our t-chart. So just like always, we put the vertex in the middle. So we're at negative 1, negative 1. We'll do 0 and positive 1, and negative 2 and negative 3. We already know that at 0, the y value is 0. So we're here and here. That corresponds to these 2 points that we already graphed. So all we need to do is put the 1 in, and whatever it is here is what it'll be there. So 1 plus 1 is 2, 2 squared is 4, 4 minus 1 is 3. So we have a point here at 1, 3, and at negative 3, 3. So now I'm going to take the coordinates of those 2 points, 1, 3, and negative 3, 3, and graph it. And then finally, we'll do a nice smooth curve through our 5 points to graph our final parabola. And now example number 2. Graph y equals x squared minus 6x plus 5 by writing it in vertex form. So notice that we were given this equation in standard form, like y equals ax squared plus bx plus c. But we want to change it to vertex form. So we have to do this by completing the square, but with a slightly different approach than we did before. So the first thing we're going to do is group the x squared minus 6x together. Within that x squared minus 6x, we're going to include our plus blank. So that is the part that we are going to complete the square because we want it as x minus h squared. So then on the outside, we have that plus 5, and this is where it gets a little bit different. Before, we always moved our constant terms to the other side, but since we're going to be graphing these, we want to keep our constant terms on one side and y left alone on the left-hand side. So whatever I add to the inside of our parenthesis here, I actually want to subtract out here to keep my equation equivalent to what I started with. So again, we're going to add a blank to the inside of the parenthesis, but then subtract a blank on the outside of the parenthesis. So once we have that set up, we're going to complete the square. So we take that b value, this number right here, and divide by 2 and square it. So we'll do negative 6 divided by 2 and then squared. So negative 6 divided by 2 is negative 3, squared is 9. So if I add 9 to the inside, I'm going to subtract 9 from the outside. So now I'll just factor this. Remember, the factorable form of this is whatever I got after I divided by 2. So I would get y equals x minus 3 squared minus 4. So now I have it in vertex form. So I'll do my 5 steps. So I'll first figure out whether I'm going to open up or open down. So this one's going to open up because my a value is 1. Step 2 is my axis of symmetry. That is this value in here. Remember, it's going to be the opposite. So it's going to be x equals positive 3. Step 3 is the vertex. The vertex is that number 3, comma, whatever the number was out here. It became a negative 4 when we subtracted the 9. Step 4 was the y-intercept. We're going to put 0 in for x. But remember, we originally had the problem in standard form. So our y-intercept is still going to be 5. And if we look at what we got after we put it into vertex form, if I do 0 minus 3, that's negative 3 squared is 9, and 9 minus 4 is still 5. So you could either go off of this or go to your vertex form to find the y-intercept. Either way, you're still going to get 5. And then step 5, of course, is to do your t-chart. So let's graph first what we have so far. We have the axis of symmetry, so I'm going to do a dotted line along x equals 3. We have a vertex at 3, negative 4, so I'm going to go over to the 3, down 1, 2, 3, 4, and put a dot. And we have a y-intercept at 0, 5. So I'm going to go up to the y-axis up to 5 and put a dot. And we know that it is 1, 2, 3 units away from the axis of symmetry. So I'm going to go 1, 2, 3 units to the right and put another dot. And now let's do our t-chart. So we'll put the vertex in the middle. So we have 3, negative 4. So I'm going to go 2 and 1 above it and 4 and 5 below it. To me, it doesn't matter whether you plug them back into your original equation or your vertex form. Again, it doesn't matter. Let's just do it in a vertex form. So if I put a 1 in, 1 minus 3 is negative 2. Negative 2 squared is 4, and 4 minus 4 is 0. So that actually means that's our x-intercept. So if I have 1, 0, then I would have 5, 0. So our x-intercepts would have been 1 and 5. And now let's put 2 in. So 2 minus 3 is negative 1. Negative 1 squared is positive 1. And then 1 minus 4 is negative 3. So it's negative 3 here and negative 3 here. So I'm going to plot those final points at 1, 0, 2, negative 3, 4, negative 3, and 5, 0. And now, of course, just connect all of your points with a nice smooth curve. So there is the graph of y equals x squared minus 6x plus 5 that we converted into vertex form and then graphed it using our 5 steps. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.